All right. Hi everyone. Welcome to our webinar today. I'm Lucian from DJI marketing team. I'm delighted to see so many of you joining us from different parts of the world. So today's topic we're going to discuss is deploying scalable dock operations in mining. Our webinars will be recorded and we will send a follow-up email with a link of the record after this webinar. So before we dive into the topic, I would like to introduce today's panelists. Today we have Christopher, CEO of RocketDNA, and Evan, General Manager of RocketDNA. RocketDNA provides strong-based geodata and automation solutions for mining, agriculture, and critical asset industries. And also we have Lumen Shi, DJI Enterprise Solution Engineer for ANZ markets. That's our panelists today. And we will have several sessions to be covered. First, Lumen from DJI will introduce the DJI Dock 2, and then Chris and Evan from RocketDNA will introduce dock use cases and the 4 pillars of implementing scalable dock operation. After that, After that, we will have a Q&A session. If you have any questions during the webinar, please feel free to drop it into the chat box and we will answer them in the Q&A session. So without further ado, I will pass it to Lumen to introduce the DJI Dock.
Yeah, hey guys, let's just start from the dock timeline. So we launched the Dock 1 in 2023 in April, and it's our first drone in box automated solution. The Dock 1 can only be compatible with the M30T dock version, and we received the first Dock 2 at very early stage in the beginning of this year, and we start the beta test with our partners RocketDNA in March to make sure that everything goes well before we officially launch it. And finally, we launch it in April this year. And the next one. So speaking of the key scenarios, so it achieves great success in security patrol, search and rescue. So yeah, this is the main application of the Dock 1, but I have to admit that we have some limitation from the geospatial side. So we understand that some of the end users really looking forward to something that's also can map rather than just focus on the inspections and the accurate flight inspections. That's why we released Dock 2 this year. So next one. So what's the difference between the dock units themselves? As you can see, the dimension is really attractive improvement. It's about just half the footprints of the Dock 1. And you can see the weight is just 34 kilograms compared to the Dock 1, 105 kilograms. Just a third of the size as far as weight goes. And now it's feasible just for one person to lift it up and deploy it anywhere you want. And you can then just mount it to max operation range, which is up to 10 kilometers compared to the previous 7 kilometers. And for the return to center system, we went from a pulling system that had push rods and a lot of moving parts, and now we just use a simple V shape in the middle of the landing ports, and it is able to replace the place well, and the aircraft can just land in the middle and slides down into the correct position automatically. And besides of that, we are now using the wireless charging system to improve the efficiency as well as the safety. So something improvements just not just on the size, but also making this simpler so that it can perform in more harsh environments. And next one. So the new models of the drones we are specifically for the Dock 2 are the M3D and the M3TD. the size is significantly smaller compared with its predecessor M30 series. So the weight is just 10 grams, but flight time is able to up to 50 minutes. It does not have folding arms like the Mavic 3 Enterprise series, and that rigidity helps a bit in the wind resistance, as well as having that rigidity assists with a little bit like the max flight time. And also we have a higher happy rating compared to the Mavic 3 Enterprise series, which is up to IP54. And speaking of the camera, with the standard Matrix 3D, we have the wide camera of 4 30-inch CMOS 20 megapixel sensors capturing at 0.7 seconds with a mechanical shutter as well. So if you are looking for implementing really accurate mapping with an autonomous solution, this is really now up your alley. You can see that the specs of the M3D camera is exactly identical to the camera of the M3Es. And for the thermal one, the M3DT equips with the typical Mavic 3 thermal camera with 48 megapixels, smaller sensor wide camera, and it also having the digital zoom camera as well. And next one is for the FlyHub 2 new features updates. So you can see that we have 5 main updates here. The first one obviously is the one-tap panorama. So now you are able to capture a 360-degree photo and look around that to provide you a comprehensive situational awareness. And this is very handy for the first response program or any emergency mission. And the second is the custom flight areas. Now you are able to set your own no-fly zones, being able to flight restrictions on how far away the drone go. And another one is cloud reconstruction. Just like I mentioned, the M3D is a mapping drone. So when we are going out and capture all the images, once the mission is complete, and now you can just have it automatically sent to the cloud mapping, and it will start processing via the cloud. And you can see that is basically a version of the Terra that we installed in the on the AWS servers. And the next is the 2D mapping comparison. So if you are flying over the site multiple times, now you are able to look from one time to another time, comparing what the differences is according to the timeline. And the last thing is the live stream share. So basically now you can generate a QR code with the link and share it with the teammates, whoever else needs to be able to view the live stream. So this feature will definitely ensure that everyone is on the same page, knowing what exactly happens on the working sites. So next one. So overall, so how is the Dock 2 different from the Dock 1? First of all, the lightweight, the size is smaller, not just easy to deploy it on the site, but also easy to ship it. And next one is, the IP level. So we have IP55 for the dock and the IP54 for the drone, which means now the whole system is more robust, even in difficult environments. And efficiency, the flight time is upgraded to the 15 minutes, be able to perform large mapping mission and also being able to do long period patrol. The 45 seconds to take off just one click and the drone can initiate the mission you require. Accuracy, now we have the drone using the timestamp on to tag the images with RDK as well as large mechanical sensor, everything you need to do the mapping. And functional, we bring a lot of new components to the FlyHub 2, and now it becomes more universal platform and very user-friendly. Cost effective, thanks for the advanced technology that applied in the Dock 2. Nowadays, the deployment and maintenance will be rather easier. The core components are all modular, So very easy to replace the old fixed dock. And the next one. So speaking of the use cases overview, so when we talk about the Docker One application, so most use cases are focusing on public safety and inspection with thermal camera. But for the Docker 2, we can go either mapping or public safety or inspection, depending on the drone you are looking for. And today we are mainly focusing on the mining application. And the next one. As you can see that over the past 5 years, the global price of gold and copper have been continuously rising. Particularly, the gold price has seen a significant increase in the past 6 months. You can see the chart here clearly show this trend, which is good news for the mining companies, as it means their profits and mining scales will continue to remain high. And in 2024, nearly 100 new mines worldwide will begin operation, with the largest projects focusing on the production of the iron ore, gold, and copper. Additionally, in the list of the global top 40 mining companies, countries such as USA, Australia, Canada, and China dominate the whole market. And the companies like BHP Group, Rio Tinto, and Glencore have significantly influenced in the mining sector. And their success is not only due to their rich resources, but also their advanced technology application and effective management. So with the increase in mineral prices, the profits and mining scale of the mining companies will continue to remain high, making important contributions to the global economy. The mining industry plays a pivotal role in vertical sectors, and the increasing number of industry players are seeking to apply new autonomous technologies such as the drones. And next one, you can see here is the main drone players in the mining industry, as you can see here, like the mine owner, the blasting contractor, and mining contractor. And today is our honor to invite RocketDNA to give you more insights regarding dock system application in mining sector. And we will hand over the presentation to RocketDNA.
Thanks, Tony. Thanks, Lucian. Let me get the right screen going. Great. Everyone can see that?
Yep.
Perfect. Good day, everyone, and thanks again, Tony and Lucian, for the opportunity for presenting to you. As Lucian mentioned, my name is Chris Clark, and I'm joined by my colleague Evan McKern, and we're really honoured and privileged to be able to show what we've been up to the last couple of months with regards to our dock deployments, specifically within the mining industry. Starting a little bit about RocketDNA and who we are. We are essentially a systems integrator, where we're taking the best of breed technologies, attaching them all together, and developing commercial and technology-based solutions that can really solve specific data problems for our customers, who are traditionally tier 1 and tier 2 mining customers across the globe. We're based in both Australia and Africa, and have been in operation for about over 12 years. Evan comes from a mining engineering background. I've got a computer science and business background, and we're really quite excited to really kind of give today a little bit about a practical example of what we've been up to and the systems that we've deployed and some of the things that we've experienced along the journey of deploying the DJI dock system, as well as give you a couple of hints and tips for yourselves and your own journeys, whether you be considering deploying the dock systems for yourselves. I can see we've only got a couple of sort of a limited time, and we want to get to the questions. So please feel free to put your questions into the chat box. We'll try to go through this pretty quickly, so we can leave some time for the questions at the end. But feel free to come back to the recording or to reach out directly, and we're always happy to sort of go into more detail later if necessary. So So what's always very interesting, and we always start off with, you know, when you think about sort of typical drone operations and where they've landed today, and as RocketDNA, we've always sort of taken it onto ourselves as this is specifically is what we do. All we do is drones and data, and being a long time supplier to the mining industry, we're also understanding what the customers require out of that. So we're if you kind of look at our team and sort of the skill set which we have, we're a really interesting bunch of sort of skills and experience. As mentioned, everyone comes from mining engineering background, but we've got surveyors, geospatial experts, aviation professionals, legal people. So a really interesting bunch of overall, I mean, sort of characters, and essentially we're really a bunch of geeks that have sort of learned how to understand what do the customers really need, how do we translate that into a viable, robust and commercial solution that can be deployed within these harsh and remote environments. So over the last couple of years, we've attained our BVLOS operations. We've been flying BVLOS for over 8 years already, on lots of other sort of traditional drone solutions as well, as including the dock. And then in the last year obtained our CASA and CAA approval, so for both Australia and within South Africa as well, to then do remote operations. So having our remote operation center approved on top of the BVLOS approvals to allow us to then fly these drones remotely. So there's just nobody at the dock itself. So we've really kind of built up a lot of experience and hours. And really complementing all our operations is our BARS certification, which allows us to really bring that level of assurance to these large global tier 1, tier 2 customers who are looking for that safety standard and that sort of skill set to understand what you need to do when deploying these solutions and operating in the long term, that it's all being done very safely. I'll hand over to Evan to kick us off. Thanks, Evan.
Thanks, Chris. As a lot of you would appreciate, on a lot of mining operations, there's a limited number of people available to operate drones and capture the data that's required. So a lot of that often falls with the mine surveying team, who have a whole range of things that they have to do. They're not just focused on operating drones, so getting the data that you need when you need it can be a challenge. So by automating the capture, you can be getting the data you need when you need it, which allows for more timely decision making and consistency in your mining reporting. Obviously, it also means that you're not requiring a pilot on site to enter the active mining area. So there's sort of the advantage of the safety sort of advantages of it as well. So to automate the capture in mining, what we've developed is what we call the XBot system. So we're taking in this case, the DJI dock and integrating with a range of other hardware systems so that we can be deploying this unit to a mine site very quickly and easily. So we simply drop this at the mine site, connect to power, and we're operating the same day. So it has the Starlink, Wi-Fi, Ethernet connectivity. We can connect to cellular networks for further redundancy. We've got CCTV camera so that the pilots in our operating centres can be looking around the location of the dock and getting that situational awareness on the ground before they take off and land. We've got a weather station, UPS providing 4 or more hours of battery backup in the case of a power failure. In a lot of the areas we operate, we're dealing with very high temperatures. So we have the option of a cooling system, which you can see attached to the side of the unit in this photo. And then all of those, all the hardware sort of components are housed in an electrical and comms panel. All the components are sort of industrial and suited to the mine site environment and are proving to be extremely reliable. It's all mounted on a galvanized steel base, so it's all shipped to the site as one unit, allowing that quick and easy setup. The data that we're capturing, we're feeding through to our site tube application. So any videos, imagery that is captured is very quickly available to the customer via that application. That also allows them to view live stream video as well. From the site tube app, then we also send the data to other third-party applications to then automate the photogrammetry processing and other reporting that mine sites typically are after. So you can see here a couple of our XBot systems with the docks set up on a mine site this is in Western Australia. We've been operating these systems remotely for 12 months now. So our first unit was deployed in June 2023. We have several of those units out there now and in Australia and Africa, and we've conducted over 3,500 flights, nearly 800 flight hours. And then more recently, we deployed our first Dock 2 in March 2024, and that we've now done, nearly 200 flights and 50 odd flight hours on that system. We're extremely pleased with the performance. The docks and the other hardware that we have integrated is all proving to be extremely reliable. In all of those flights that we've conducted, we have not had any issues with the dock. The only issue we have had is a hailstorm, which caused some damage to the lids on one of the docks. The system continued to operate without any issues. And then the next day we had the technician on site and replaced those lids within a couple of hours. The maintenance on these systems is pretty straightforward, and our team technicians in RocketDNA are trained by DJI in the maintenance of those systems. We've been through, we've been operating these for a year now. So we've been through a Western Australian summer where these have been operating daily in 47-degree heat. We've had flash floods, hailstorms, we've had the whole lot, and they're proving to be extremely reliable.
We're just waiting for the locusts now, hey, Evan.
Moving on, so these systems are monitored by our pilots in our remote operating centres, which are currently in Perth and Adelaide in Australia and Johannesburg in South Africa. What you can see here is the main screen where the pilot has his flight planning and monitoring software, in this case the DJI Flight Hub 2, and there's various other screens providing weather information, so the real-time weather from the XBot unit, as well as internet-based weather information for providing to get forecasts on wind and so forth. We've got air traffic display, the CCTV camera view, which the pilot can control from the from the remote operating center, and we've got our VHF radio over internet system. So on the sites where we have these units, we have the radio system on site, and we are communicating with air traffic in the area remotely from our operating center. For mining, there's we find that the mining customers are using the dock for a pretty broad range of applications. Typically, they'll justify the system based on surveying, so your typical stockpile surveys, open pit surveys for volumetrics and conformance reporting and that kind of thing. But once it's up and running on site, people quickly come out of the woodwork and request all sorts of things. We do a lot of data capture for geotech. So, you know, getting very detailed pit wall models, doing pit and you know, berm inspections on a regular basis, and just getting a good overview of the site on a regular basis. So for most sites, first thing in the morning, the drone is going out and doing a flight where it's capturing a series of panoramic images and videos. It's landing, and then within 15 minutes, that information is on the SiteTube app, and the customers are able to see exactly what's going on the site, whether they're on the site or whether they're in their head office back in Perth or on the other side of the world. A lot of uses also, it's being used a lot for drill and blast, pre and post blast surveys, and various inspection work as well. A lot of the data we're capturing is going to other applications. An example here is Straios, where we're their photogrammetry process and a lot of the reporting that the mines are after is automated. So we've got, so you can see here the volumetric reporting of stockpiles, conformance reporting of the open pit versus their pit design. And similarly for haul road reporting, that's becoming a lot more popular here amongst the big iron ore mines, where they're running autonomous trucks, and the conformance of haul roads is a significant thing to report on. I've mentioned the geotech work that we do a lot of that. In this example here, the geotechnical engineers on site contacted our remote operating center and notified them that they'd had a slip in the pit wall. Our pilot immediately created a small mission. We flew that, and in about an hour and a half after the call to the remote operating center, this 3D model was available online to their geotech engineers, who were mostly based off-site. So really enabled that high-res detailed information to be captured and shared extremely quickly. Drill and blast, we do a lot of pre and post blast surveys. A lot of that data often is going into applications like Straios or ORPRO 3D for prediction of the heave and automated reporting of fragmentation. And emergency response, we've done several, been involved with several mock emergency scenarios on mine sites. So there's one example you can see in the imagery there. There was they were doing a cyanide spill emergency scenario. They called the remote operating center, and we sent a drone to the location immediately. The drone was live streaming the video to the incident control room and also to the mine rescue vehicle. And the drone was on site about 5 minutes before the mine rescue team were able to get there, and it was providing fantastic situational awareness for quite a while before people arrived. And we have also been involved in search and rescue type scenarios at night time. And then our team in South Africa as well are doing quite a lot of day and night security patrols for mining operations over there.
Perfect. Thanks, Evan. And for my sort of side, and I think what's been very interesting for RocketDNA over the last year, and what we're very interested in sort of sharing with everyone today, is our journey in the practical implementations of building your doc program out. And I think what's probably very important to sort of note is, I think when a lot of us sort of start off on this, we're all sort of only envisioning, one drone to sort of start off, but a lot of us don't sort of have yet sort of begin to sort of comprehend the true potential and the power of automating your entire sort of drone data capture system. I think the days of sending people into these dangerous areas is sort of long gone, specifically within the mining industry, and really bringing back all those engineering and surveying skills back to the office so they can focus on the insights and reporting, and really letting the drone in a box or the doc do all the hard work. And really what we want to share with you today is no ways comprehensive, but some of the interesting insights that we've really picked up over this last year in deploying and scaling these drone operations. So I know a lot of this may sort of come across as quite new, or there's quite a lot of information there, which we're going to sort of briefly touch over. But ideally, with sort of the 4 key pillars, what we want to really have a look at and share with you today, and really kind of get you started when considering deploying your doc operations, is what are you really looking to automate? Because I think a lot of us sort of picture and imagine, say, well, I've already got an M300, an M350, I'm doing those automate, we've got enough capacity, skills on site. Is that really, what is the sort of the pain point that you're trying to actually look at when you try to automate any kind of system, let alone just a drone data capture system? We're also going to have a look at the technology stack. How will you integrate the stock within your entire system? So again, trying to compare this versus your legacy or traditional drone systems, there's more to it when bringing a doc on board. Then we'll sort of lightly touch on the regulatory and safety aspects. I think there's a lot of information out there with regards to beyond visual line of sight and remote operations, which is generally pretty nuanced towards each operator and how you will do sort of operate these systems safely within your site. But we'll share a couple of insights into what we've picked up and what's important to regulators as you go out and build your operations and policies. And then lastly, the return on investment. We understand many of you are coming from a technical background, and you probably need to go and sell this new solution internally to other stakeholders as well. And we want to give you a couple of bit of tips on how you can do that as well. So lightly kind of thinking about the operational workflows, our very first pillar today. And I think what's really important to sort of start off is that you can't treat your doc operations with the same mindset as you have been with your traditional manual drone operations really to date. It's a very nuanced product, and it's got its particular niche in that you're really looking to ideally automate scenarios which you already are using drones or aerial data for on a very frequent basis. And so what's really the beauty of deploying the doc specifically within mining scenarios is that there are a couple of quick wins in terms of the areas and the endpoints as well. Be that ROM stockpiles, pit inspections, or blast videos, which are typically recurring, on a daily basis. And these are those kind of applications that fit very, very well within for the dock system as well. As sort of mentioned earlier, the dock really has got a very big safety factor to it. You know, removing humans from what I call the 4Ds. You know, it's those dull, dirty, dangerous, and dear tasks, things that are important but have to be done on a daily basis. And really, the ideas of deploying engineers out there to conduct just simple data capture tasks. You know, the sort of the industry, and I think the sort of the labor market is sort of now evolving, where everyone's getting very comfortable in using the software tools provided and leaving the data capture up to the automated systems. It's also really about considering how is this data going to be used. You know, the first thing when you're going to automate any kind of system is that you essentially are looking to remove a human out of the loop. What are you going to put in replace of that? And we'll chat a little bit more about what we've done to address a couple of those gaps as well. But it's really about how do we then try and look at achieving not only the same data capture rates, but of getting more data more frequently, how we're going to process all of that so that we can really kind of take advantage of this permanent sort of installed capacity put onto site. There's really a sort of a big question around then what are your internal skills in looking at on site. Again, deploying a dock with drones, they're very two different beasts, and you got to sort of look at bringing on skills and people to help you know, sort of run that in parallel to make sure that there's no conflict, not only from a sort of a physical sort of approach, so you sort of managing the deconfliction and the safety around that, but also how you're going to do this safely. You know, in operating autonomous systems where you have a remote operator that's not on site, what are those new communications sort of procedures that you're going to bring on board? And then really it's about considering that physical environment. So you sort of might have seen in the previous image, you're now establishing large sort of areas of where these docks are going to be sort of permanently or semi-permanently placed. We've obviously designed ours on a steel-based skid, so there's no digging, you know, required. You can sort of place it and go or lift it when you need to. But there's a really big context between the permanent and mobile operations, and you know, a lot of people would have said, you know, why not sort of, you know, put your unit on a trailer and deploy it like that? And we've sort of said, look, if you're looking for a mobile solution, people are typically they're going to go back to your traditional way of flying a drone, which is putting the back of your boot and flying your M300. And so we really wanted to focus on, again, solving the particular workflow, which is those areas where you need a high level of frequency and accuracy and robustness and consistency in your data reporting. And that's really the game that we want to focus on, because, you know, setting up these systems is quite a lot of work. There's a lot of, like sort of Evan showed, the skid, the XBot solution that we've got is a ready to deploy skid, but there's a lot of radio and other work and procedures around this that go to complement it. So it's a very big commitment that you've got to make and have the buy-in of all the stakeholders around to implement these systems on site. Because ideally what you're looking to do, speaking to point 3 here, is you're looking to automate the entire data workflow. You don't just want to only focus on automating just the data capture. You want to go from beginning to end of removing the and streamlining essentially the entire data steps from that data capture to the processing, and possibly bringing in a couple of other tools, whether that be AI or software that you already own, to really start doing some of that preliminary sort of reporting. And that's really about giving all your team on site not only a seamless experience, but a lot more capacity as well. So at a very sort of high level, what can you expect when you deploy one of these systems? And kind of playing on the puns of sort of RocketDNA as well, you're using your systems, you're doing your initial sort of mission planning, and maybe a quick point on that is when you're doing these systems, and when we're deploying these systems, it's not the first time, you know, when you sort of just sort of put a unit out there, deploy it, and start flying immediately. There's a lot of safety considerations that involved, you know, in assessing the ground and air risks that are needed to deploy these systems as well. Once that has all been sort of documented and assessed. That's then all shared with the remote operators, who then sit in our remote operation centers and then conduct all those pre-flight checks and radio calls and communications and make sure that it's safe to fly. So not only from the other drone operators and any other kind of ground risks, but also other air traffic that's operating in the area and performing the deconfliction where required. We're then monitoring those drones in real time. So you're getting the video stream, you can see the location. You're also monitoring all the air traffic as well and making those radio calls on a continuous basis. And as Evan mentioned, the drone then comes back, lands, recharges, and then this data is either then can be pushed through Flight Hub as well, or can be then integrated with third-party software and solutions, which the clients may already have on site. So speaking to that, let's consider sort of the hardware stack, because a lot of what everyone really sees is sort of the front end, is that hardware part, which is really great. And I think DJI has done an incredible job in really to help create a lot more excitement and accessibility within this market for drone in a box overall. And what we're seeing is the tick boxes are. There's a lot of work and components involved, even in delivering the hardware. So what we found is that while you've still got the dock, there's a lot of safety systems and requirements are wrapped around that. So as an example, our XBot has up to 60 separate components that all make up the entire XBot, and the DJI dock is just one of them. So there's a lot of these things that you need to consider when you're building the hardware to be able to not only operate these things truly remotely, because that's I guess the idea. What everyone wants to do is really place these and have very low touch sort of regimes around this. You don't want to be going back to the dock every single day to check on it or to repair it or to move it and really to do that maintenance. You want to be able to deploy these to these very remote areas, which are generally logistically difficult or got very sort of treacherous sort of environments as well, because you want to remove humans from there ideally. And so you've got to think about all the hardware components and all the safety systems required, not only to operate it safely, but also then to pass the regulatory sort of muster. Because what you're essentially doing when you're building these hardware systems is you're simulating the pilot if they were on site, but now from a remote operations center. So there's a lot of other sort of sensory tools that are integrated to really give you that as well. Then it's considering, well, now in an enterprise, for our tier 1 and tier 2 customers, how do these systems then integrate with the rest of our technology and infrastructure as well? So looking at these large customers, you've got to be able to answer and integrate and sort of tick the boxes around that cybersecurity, and really be able to understand what is the correct architecture that's going to solve the problem versus, and when we kind of talk about on-prem versus cloud, because while the dock is inherently built on a cloud platform, you can take advantage of a lot of other cloud tools to help you, again, automate that entire data workflow. But considering customers have made a lot of commitments or investments in existing software, how do we take advantage of all of that and still allow the customer to either process or to use those existing tools in a phased investment approach to incorporate the dock and allow them to really expand slowly? And as sort of Evan mentioned, you'll start with one, be it survey, and slowly grow that into a geotechnical, geology, or other use cases. So when we're designing these systems out for our customers, we're sort of showing them the multiple sort of options available to them, and what we really like about the XBot solution that we've sort of designed is that it's exceptionally modular. So everything that we're sort of showing you today can be sort of cut and changed, and adapted and customized for the end user and their particular scenario needs. And we're understanding, we're very happy if the customer only wants the hardware, we'll only send the hardware. If they need help with integrating the software, we'll do the software as well. And this sort of diagram gives them an idea of, right, what is possible, what can be done. So once you've deployed the XBot to site, we're then sort of focused on, right, how do we then get the data processed? How do we then get the data sort of shared? And once you sort of figure this out, and this is a really great cloud example, is that the the power of the dock and the XBot system, once deployed, is going to streamline all your data capture, because what we're seeing is hundreds of people who are all using drones on site, all flying, capturing exactly the same information, the same pit, and processing it for their own needs. And the beauty and where we're seeing some of the efficiencies gained is the ability to just fly once, provide a single platform which can then be shared with many users over time. Because if you know that your data is being captured reliably on a day-to-day basis, you can go in within your library of data and access that data set and process accordingly. A cool little sort of link, Evan was mentioning our SiteTube application as well. This is just a bit of a screenshot of the live streaming component of it. So we'll have some customers who would like to locally host their data either on-prem or within their jurisdiction or country, and we fully understand, appreciate that. That's why we went out and developed the SiteTube application. This allows us to host the customer's data on local AWS servers, be that either ours or the customer's their own, and then really on top of that to provide a visual front layer for all their end users to be able to access that data, be it the photos, the videos, the panoramics, or even the live streams as well. And really what this does is that it solves that removing of the human element. So traditionally, you've got drone pilots going out there, flying your M300 or M350, capturing data, and then coming back, processing it and handing it on a USB or thumb drive to the actual end user of the data. And when you put a dock system in, you're removing that human. What is the system to that? And our SiteTube application is the answer to that. Briefly over the regulatory side, I think just picking out a couple of these, what's really important and where we saw a very big difference between the legacy traditional BVLOS operations and then the remote operations as well, is that you've got to understand it's two separate things. BVLOS it's a full-time job. This isn't something we would recommend someone sort of do as part of a current role. I think flying VLOS or EVLOS, that's perfectly fine. But I think just be very, very conscious and cautious of consultants or people that sort of promise you the world that say, oh, we've got BVLOS, we'll cut and paste and really give it to your operations. We've really only just seen that end in sort of failure. It's a full-time role, and for those companies and team leaders who are considering taking BVLOS and remote operations on, you really got to make that full commitment into not only setting up that physical environment, but also within the regulatory process as well to achieve those approvals. And a big thing to always understand is that remote operations doesn't mean it's unfamiliar or new territory. You're gonna be proving to the regulator that you understand all those ground and air risks as well, and that you've documented it and sort of brought that back into the remote ops environment, so that any person who picks up the mission for the day knows what they're getting themselves into. Talking about the remote ops center, now that's quite an interesting scenario because when you've got a lot of sort of tasks and flying for the day, it's really about developing that task management system, that capacity and that rostering for those peak times of days. And we've really kind of, as RocketDNA, focused a lot on effort and attention in developing the perfect operational structure and coordination between our teams via remote operating centers to ensure that all your tasks are pretty much done early morning with the ad hoc capacity there for any kind of emergencies or sort of ad hoc requests that come through. And another important element when you're training up your remote operators as well, while there's a lot of BVLOS training as well, we've typically employed commercial airline pilots because there's a lot of benefit in bringing on operators who've got an IREX or an instrument rating within the systems as well, because that's essentially what you're doing here. If you think about it from a traditional air traffic point of view as well, is that we're really looking at how you're separating the person, how do they rely on those systems and use those systems in the most effective way possible to deliver a safe overall solution. And sort of chatting about fatigue management, all that cybersecurity, all that compliance, your emergency response training. So you can kind of see it's really it's a full-time role and a solution that should anyone consider going to remote ops, it's something you sort of don't want to go in half-heartedly. You sort of want to go all in on doing it correctly. And then to quickly end off, maybe a couple of quick tips for those of you who are looking to do then internal, sort of get the buy-in for the return on investment for your dock operations as well. It's really about defining those measures of success. You know, what are you really looking to do, and identifying those key KPIs within your organization and its culture. And then really it's about breaking that down to the first principles. So understanding, what are you currently spending? You know, do you have a lot of satellite pits where you're sending people out, they're taking hours to drive out to these remote locations just to spend 10, 15 minutes capturing data and then coming back? How can we simplify and automate that? And then it's really about considering the scalability, because that's really why we're all here today. It's not just about deploying one dock solution. You know, a lot of our customers are looking at this going, how do we have 3 to 5 to 10 across, you know, each of our sites, and then how we're going to manage this at scale. And that's really the exciting, you know, where we've got to be viewing all of this, and then appropriating the savings across that, and where those efficiency gains are going to come from. And I think, again, the last sort of point is just identifying what are the boundaries and constraints. Well, technology is there to enable. We also realize, you know, you're going to have those sort of constraints, and identifying those and planning for them in the early stage will help you manage the expectations and those stakeholders as well. So we'll sort of probably leave it up to there and hand it over to questioning. But as the last sort of one, for those of you who are interested, we're running a round of live demonstrations as well, either online or coming to a city near you. So feel free to book on the registration link there, and one of our team members will give you a call to actually give you a live demonstration from our remote operating centers. You can come and either see us in Perth, Adelaide, or in Johannesburg, or online, and we'll fly for you remotely. So thanks over, and thanks Lucian and team.
Thanks, Chris. Thanks, Evan and Ruben, for all introduction. Now we are going to jump into the Q&A section. I think we will have around 15 minutes for the Q&A session. So many questions in the pool, and because of time limit, we will just select some of them. And for other questions, we will answer it via emails or directly in the chat box. And the first question, I think, is for Lumen from DJI. First question is, what's the minimum interval between two operations of DJI Dock 2?
So basically, the minimum interval between the two flights, you can say, is the charging time. That is approximately 35 minutes. The aircraft battery will be charged from the 20% to the 90%.
Okay, thank you. And the second question is still for Lumen. Does the DJI M3D series support manual flight with the RC Pro?
That's a good question. Technically speaking, you can do that, but due to limited functions, we strongly recommended that only use the RC Pro to complete the initial configuration, and link to the M3D series as just like a controller B.
Okay, thank you for answering questions. And I saw so many questions in the polls for RocketDNA team. I think I will just pass it to Chris and Evan to let you guys answer the questions.
Sure.
It's one of the ones that's come up a couple of times is the does the XBot system meet CASA requirements? So the answer to that is yes. We've been operating our system for a year now remotely with CASA approval in CASA approval in Australia and CAA approval in South Africa. So your sort of the hardware and how we've got that set up is all assessed at the point of doing your getting your approval with CASA.
Yeah, and I think the most important thing is that, again, while the hardware is just one part of it, I think when you're approaching the regulators for any kind of approvals, it's the hardware plus your procedures, your policies, your maintenance, the remote ops center. There's multiple sort of components together that make up your overall approvals.
Yep. Is a strong internet connection required? You need a decent internet connection. In the mining environment, we typically don't have access to a nearby Ethernet connection, and what we find is we are mostly using Starlink. So the Starlink is proving to be extremely reliable, and the speed is pretty good, and that tends to be the way to go. And then we're using other internet connections more so just as a redundancy.
Yeah, I think also to take full advantage of the opportunity that the dock presents in terms of very frequent data collection. Having a high-speed connection, not only gives you that high resolution video streaming, but allows you to have multiple data sets, being delivered on a daily basis.
Yeah. What is the maintenance schedule and the cost of upkeep for the system? So the maintenance schedule, really not a lot involved there. It's a fairly, as Chris mentioned earlier, we design these systems to just stay on site and not have to have somebody there all the time babysitting it. The main maintenance, I would say, is just a general inspection and clean. Obviously on a mine site, things can get very dusty. So what we typically have the customer doing a weekly, just very basic check and wipe down, clean the system. The dock and drone scheduled maintenance is it's fairly basic. There's it's every, I think it's 300 flight hours, there's a service. A lot of that is really more so an inspection, and then from time to time the drone would be returned to DJI or an agent for a more thorough service. There's not a lot of moving parts on the dock. It's proving to be extremely reliable. And then the cost of the upkeep, well, pretty minimal with the managed sort of services that we provide. We include maintenance in our monthly fee, and it's a fairly small proportion of the fee.
Yeah.
Does the dock have? Sorry.
Go for it, Evan. Sorry.
Does the dock 2 have RTK module? Yes, it does. It is a proper RTK survey type drone system. The dock doubles up as your RTK base. So when you first establish the dock on site, then there's a reference mark on it, and you survey that point in just as you would with your conventional RTK base station. We have another there, just asking about how do you go about getting approvals for simultaneous operations?
The one to many.
Yeah, it's very interesting. Chris?
Yeah, it's a very interesting question, and it's definitely the way that everything's going to be going. So it's about practically demonstrating that you can do it safely. So sort of starting off on your single drone operations, and then building that up over time as you get to site. And some of the questions you're going to be asked is, again, how do you mitigate against your drone operations versus other drone operations, and then how do you deconflict with the manned traffic? And should any kind of air traffic come into your area, what are the procedures around that? What if one of your drones experiences an issue? How do you then handle the other drone in the area? So you can see a lot of these kind of questions can't just be answered by as a hardware or software problem. Some of them have got to be really built in as part of a procedural or an emergency response policy as well.
Is it possible to carry out inspections of machine parts in the mining site? Yes. We do a lot of inspection applications, whether it's both fixed plant and mobile plant. The M3D, which is your standard sort of, is the drone that you would be using for survey, does have a good zoom, RGB zoom camera on it. So yeah, get a lot of use out of that for general inspection applications.
Thank you guys for sharing all this information for today. I think our webinar is very insightful, and now we'll call it. And we'll send the follow-up emails later to you guys. And thanks to everyone for joining us today. I hope you have a great day, and we are hoping to see you guys in our following webinars. Thank you.
Thanks, everyone. Go well.